Okay, so now for more examples on area between two curves. This is the second type. This is a type where they do not give you the boundaries. You have to find them. So remember, the boundaries are going to be the points where these graphs intersect with one another. And where they intersect, we also know that they are equal to each other. So it's that simple. If you need to find out where two graphs intersect, you set them equal to each other. So 2 minus x squared equals x. And then pretty much with all of these, you're going to need to move everything to one side and then factor. Anytime you see x's with different powers, like here we have an x squared and an x, that's a good sign that that's what you need to do. So I'm going to move everything to the right side because I want my x squared to be positive. Gives me that. And then that will factor to be x plus 2 and x minus 1, which gives me boundaries at negative 2 and positive 1. So when I set up the integral, it's going to be from negative 2 to positive 1. Now I've got to decide which one goes on top. So again, if you look at this, actually let's back up. We need to consider our boundaries. So those are our boundaries. We're going from 1 to 2, negative 2 to 1. An easy number in between that would be 0. So if I plug 0 into f, I get 2. And if I plug 0 into g, I get 0. So clearly 2 is bigger than 0. So that means the 2 minus x squared comes first. So 2 minus x squared minus x. Okay, again, it's my preference to go ahead and simplify that first and reorder it so it's negative x squared minus x plus 2. Then I take the antiderivative. Plug in the top number minus the bottom number, so I plug in 1. Then I plug in negative 2. Okay, negative 2 cubed is negative 8, times negative 1/3 is positive 8/3. Negative 2 squared is 4, times negative 1/2. Negative 2 times 2 is negative 4. And when you work all that out, you should end up with 9/2, or 4.5. Either way you want to write it is fine. 9/2, or 4.5. Okay, so now let's look at another example. It says find the area of the region bounded by f of x equals 3x cubed minus x squared minus 10x, and g of x equals negative x squared plus 2x. This is another example of one where we are not given the boundaries, so we have to find them, and the boundaries are going to be the points of intersection. So again, we find the points of intersection by setting the two equations equal to each other, because where they intersect, they have the same point, so they're equal. This time we move everything to the left side. I just always like my biggest power to be positive, so that's how I choose. But it really doesn't matter either way. If you add x squared to both sides, they just cancel out. Then subtract 2x to get minus 12x. Okay, first rule of factoring is always to make sure you know which one, or excuse me, if there's anything in common. So we have to look there first. These two pieces have 3x in common, so I can pull that out front. And then x squared minus 4 becomes x plus 2, x minus 2. And I have 3 points of intersection. I get 0, negative 2, and positive 2. Well, that's different. So let me pull up the calculator so you can see what this looks like. Okay. So in y equals, we're going to plug in 3x cubed minus x squared minus 10x. And then in y2, we plug in the other one, which was, let's see, negative x squared plus 2x, okay? Negative x squared plus 2x. Alright, let's check out the graph here. Okay, so you can see that there are two regions. We have one region. We know they're at negative 2, 0, and 2, so they meet here. And there's one of the regions right in there. And then they meet at 0 and 2. Here's the other region right there. Okay? That may have actually made it more difficult to see, so let me erase that. But there's two regions in there. So this means we're actually going to have to find two different integrals, because if you can tell, it switches which one's on top. The cubed function is the one that looks almost like a giant N. That's on top for the first one, and the squared function, which looks like just an upside down U, that is on top for the second region. Okay, so the first one, like I said, would be from -2 to 0, and the cube function was on top, so we do 3x cubed minus x squared minus 10x minus -x squared plus 2x. Now we have to add to that our area of the other region, be from 0 to 2, and we have the opposite on top, -x squared plus 2x minus 3x cubed minus x squared minus 10x. So we have to add these two results together. Like I said, I prefer to simplify, so now the -2 to 0 is going to become 3x cubed. The x squareds cancel out. -10x minus 2x is minus 12x. I have to add to that the integral from 0 to 2. And when you simplify that, it should just turn out to be the exact opposite, -3x cubed plus 12x. Okay, so now I take the antiderivative, and I get 3/4 x to the 4th minus 6x squared from -2 to 0 plus -3/4 x to the 4th plus 6x squared from 0 to 2. Okay, so we're going to need to plug these numbers in. If I plug in 0, I get 0. If I plug in -2, let's see, I should get -2 to the 4th is 16 times 3/4 is 12. And it'll be minus 24. And I add to that. Plug in 2 gives me -12 plus 24 minus 0. Okay, so if I got all my signs right, this should turn out to be 12 plus 12, which is 24. So the area between those two curves at their intersections is 24. Now just so you know, it turned out this way, that each region had the same area. They were both 12. That's coincidence. That will not always happen. It certainly could happen again, but it's not guaranteed to happen. So the area between these two was 24. So keep in mind, if there are three boundaries, you are likely going to have to set up two different integrals. And the reason for that is that it often switches which equation is on top. Okay, at this point in class, I had them look at page 418, number 1 through 6, and just simply had them look at how to set up those 6 pictures there. So if you want, now would be a good time to pause the video and try these out. Just try to set them up. I'm going to pause. I'm going to just be quiet for a second or two to give you a chance to pause, and then I'll put the answers up. Okay, so if you did those on number 1 through 6, there are the answers. So again, you're welcome to pause here and check your work. Okay, moving on. Let's try this one right here. So we find the area of one region bounded by sine of x and cosine x. Now you may be wondering, why did I say one region? Let's look at the calculator and plug in sine of x and cosine x. And check out that graph. If you can see, it actually intersects infinite number of times. It just intersects and intersects and intersects and intersects. So it's got lots of these little tiny areas right here. Got one there, and there, and there, and there, and there, and there. Now they're all the same. They're just mirror images of each other. So we're just going to find the area of one of them, because if we didn't find the area of just one of them, the area is actually infinite, because they just intersect an infinite number of times. So let's go back and figure that out. Just one region. So we got to figure out where they intersect. So to do that, we set them equal to each other. And you have to think, where on the unit circle do these two have the same values? And that's actually at pi over 4 and 5 pi over 4. At pi over 4, they are both square root of 2 over 2. And at 5 pi over 4, they're both negative square root of 2 over 2. So I would set up the integral from pi over 4 to 5 pi over 4. And the top one, if you look back at the picture here, is sine. I'll see if I can highlight sine for you here. So sine's in red, cosine is here in blue. So then the region we just found is right there. So sine's the red one, sine is on top. Sine of x minus cosine of x, because it's always top minus bottom. If you didn't have a graph, remember you could pick it something in between. So for example, pi. Pi is in between pi over 4 and 5 pi over 4. So if you plug in pi for sine, you should get um, get 0 for sine of pi, and cosine of pi is negative 1. So 0 is bigger than negative 1, so it goes first. So then you take the antiderivative. The antiderivative of sine is negative cosine. The antiderivative of cosine's positive sine. Okay, so we just keep the negative in front because it doesn't change signs. And we do that from pi over 4 to 5 pi over 4. Okay, just for the sake of time, I'll just tell you when you plug that in and do all your subtracting, you should end up with 2 square root of 2. 2 times the square root of 2, which is, I guess, about 2.828, something in that neighborhood. I'll double check that. Give me a second. 2 times the square root of 2. Yes, 2.828. Alright, just one more example. And that's this. Find the area of the region bounded by x equals 3 minus y squared and x equals y plus 1. Well, this is just a rough sketch, but looks something crazy like this. So one thing you could choose to do is basically turn your head this way. Turn your head sideways so it looks more like this. But truthfully, you really don't even have to worry about it. You can act like this is just normal. You can act like the x's are y's and the y's are x's and do this exactly the same way. So I'm really just showing you this to let you know not to be intimidated if they flip the variables on you, because it's going to work exactly the same way. We need to find where they intersect to use those for boundaries. So we set them equal to each other, add everything over to one side. We get y plus 2, y minus 1. So our two boundaries are going to be negative 2 and positive 1. So when I set this up, it's going to be from negative 2 to positive 1. I need to figure out which one's on top. Okay, so my boundaries are negative 2 to 1, so 0 would be a good number. If I plug 0 in here, that's going to give me 3. And if I plug 0 in here, that's going to give me 1. So clearly the 3 minus y squared would come first. And I subtract that from that y plus 1. Please remember two things here. Put parentheses around the y plus 1 and put a dy at the end. We're dealing in terms of y, not x, so put dy. Alright, now let's practice this one in the calculator. Let me pull the calculator over to this side. Let me erase that. Okay. You can do these in your calculator. Now you need to know how to do it both ways, because some of them are simple enough you can do without, some of them are complicated enough you've got to do it in your calculator. So you need to know how to do both. So we use Math 9, which is the same thing we used before. You just got to be very careful with all your parentheses and such. So we do 3 minus x squared minus parentheses x plus 1, close that parentheses, comma x, comma negative 2, comma 1. And we get 4.5 for that answer. Alright, so that's it. Homework for this section was